Greetings engineers, welcome to this webinar on concrete building analysis, design and detailing. We'll be using three programs, RAM structure system, RAM concept and RCDC in this webinar. So the agenda for this presentation will be approximately 1 hour, starting with a suggested workflow for this concrete building project. Step 2 would be the actual modeling of concrete building in RAM structural analysis, and step 3 and 4 would be the lateral loading and finite element analysis of the building, and step 5 would be the concrete design and detailing using RCDC program, and finally step 6 is the mat foundation design using RAM concept. So let's go to the first step now. Okay, the workflow, the suggested workflow. We could do the modeling using any multidiscipline building information modeling program like Open Building Designer, Bentley's Open Building Designer, or Autodesk Revit, and we can import the model through ISM using RAM structure system, and we can finish the analysis here and proceed with design using RCDC, otherwise called as Stair Advance Concrete Designer, and then the slab design and mat foundation design using RAM concept. If the slab is made of flat slabs or post-tension slab, then it's RAM concept, or if it is a simple one-way or two-way slabs, then RCDC will be good enough. Okay. For this workflow, for this e-seminar, I'm going to use RAM structure system for the modeling, because just like a BIM program, a RAM structure system also is based on physical modeling. So either we do the modeling in a BIM program or a structural analysis program like RAM structure system is the same method, same way. So first we'll do the modeling using RAM structure system, RAM modeler. I'll show you how to import grids as well as creating a new grids, and I'll show you how to create the model quickly, perform integrity check and gravity modeling. Then step 3, we'll do the meshing of the physical model, and we apply some lateral loads, we create some stage construction, perform analysis and load combinations and post-processing. Stage 4, we perform the concrete gravity analysis in RAM concrete and make the model ready, suitable for using in RCDC. And then finally in stage 5, we use the RCDC program to perform the design and detailing. Stage 6, we'll use the mat foundation design using RAM concept. So with that, we'll start with a live demo, and I'll show you the step 2, which is modeling the building. So before I start showing you the modeling, I just want to show you the completed project of this 10-story building. This is what I'm going to model today. Okay, it's approximately 6 meter into 7 grids. There's 42 meter in the length and 25 meter in the width. Okay, 10 stories each. The ground story is 1.5 meter plinth level. Okay, and the first story is 4 meter, and the remaining all stories are 3 meter. Okay, and here we have a shear wall lift core. Okay, and 2 shear walls on each face of the building. All the red color columns are all lateral columns. I have 1 meter interior and 750 mm exterior columns, and most of the beams are lateral beams, except the beams which are connecting to the shear wall are simply supported, and hence they are modeled as a lateral, gravity beams. Okay, so you can see some blue color beams, red color beams. Blue color beams are gravity beams, red color beams are lateral beams. And columns, I don't have any gravity columns, all are lateral columns. Okay, and the shear walls are also lateral. Support, we have almost all type of supports, isolated footing for the exterior columns and pile cap for the interior columns, combined footing for the shear wall, and mat foundation for the lift core. So that gives a good idea about the building which I'm going to create. Okay, so I start with a new file. So I call this file as 10-story building webinar. Okay, SI units. And here's the RAM structure system first screen, RAM manager. And notice that this program is not just for concrete buildings, but also for steel buildings and composite buildings together. Even you can use it for other material as well, not just for steel and concrete. So first I start with the RAM modeler and choose my material as concrete. The first step I should do is creating the floor layouts. For this example, I'm going to create 3 floor layouts, typical one, and roof. Okay, so I'm going to use the typical layout, and I'm going to import and show you a DXF file import. Okay. Before you import, you make sure you look at the grid DXF file in the CAD program and note down the level names, okay, of the grid, okay, and use the correct level names here. For the grids is here for this DXF file which I got is level grid, L grid, and then for the grid labels I use this L grid text which is used in the DXF file. And notice that if the DXF file contains the slab edges, slab openings, you just need to note down the levels and choose the levels accordingly so that everything will get imported. Okay, so you can see that I imported the grids along with the curved grids, inclined grids as well. Okay, but for this example, I'm not going to use this grid. I'm going to create a grid myself. Okay, so I recreate the file instead of deleting the imported grid. That will be faster. And go to the RAM modeler and repeat the same procedure. Layout type typical, and typical 1 and roof. Okay, and I choose my typical layout, and this time I'm going to show you how to create the grids. Last time I imported the grids to DXF. Okay, so now I name this grid as say column grids. Okay, and then I'm going to create the grids and add the X direction grids, label it as alphabetical starting from A with a grid spacing of 6 meter and 7 grids. So 7 into 6, that will be 42 meter total in length in X direction. Similarly in Y direction, I'm going to label my grid starting from 1 and grid spacing I'm going to use 5. Number of additional grids is 5 and a hair is 25 meter. Okay, and the middle I'll be adding another grid with a grid label of 3.1 meter, which will be using 13 meter from the origin. Okay, this is the one, 3.1. Like this, you can add intermediate grids anywhere you want. Okay, so now I choose the grid for this typical layout, and I'm going to draw my columns, okay, on the grid or off the grid. So use these tools here. I use a standard column. I model the column as a lateral column. Choose the orientation here, and choose the material as concrete. Okay. Okay, now you can see I've finished modeling all the columns. I'm going to delete certain columns by putting a fence. This middle columns, middle grid, I don't need the columns there. I'm going to create a shear wall here, so I delete the nearby columns as well. Similarly here, I'm going to create shear wall, okay, here as well. So I delete these 4 columns, and here as well, I delete the 4 columns, okay. So I finished modeling the columns. Next is walls on the grid. Use lateral and 300 mm thickness walls. Okay, here and here. Here. Finished modeling the walls. Next is beams. I'm going to use on-grid lateral as well. Okay, as far as possible, I'll try to use the fence command to automatically create all the beams. And the location where it's connecting to the shear wall, I'm going to model the gravity beams. These are not created automatically because for automatic creation, you need to have the columns directly connecting to the beams. Okay. Since these beams are not connecting directly to the columns, they are not automatically created. So I need to create them manually. Okay. Next, these 2 beams, I need to delete it and replace with a shear wall. Okay. So I go to the wall modeling tools and use the lateral walls 300 mm, and I'm going to model a shear wall lift core here, 6 meter by 3 meter, and going to do the modeling of the beams, the simply supported beams from here to here, here to here, here to here. Okay, and now need to check the release of the beam, the fixity of the beam. All the lateral beams will have end fixity. Okay, here I missed a beam, so I go and add this gravity beam here. And all the gravity beams are having major and minor moment release. The third release is torsion, which is not released. Okay, so this I need to correct by using the modeling option, layout beam, assign beam fixity, and left is going to be released, on the right side is going to be fixed, so I'm going to use fixed, major fixed on the right side, minor fixed on the right side. I'm going to use single and correct it here. Okay, same way I have to do it for the left side. It should be pinned, so I use left as pinned. Okay, here. Same way I have to do it here as well as here. No, not here, sorry. Here should be the other way. Fixed on this side and pinned on this side. So left is fixed and right is pinned. Okay, so same way I have to do it for all of this here. Okay, here should be both ends pinned because they're connecting to the wall. Here left should be fixed, right should be pinned. So same way I have to correct it to all these gravity beams. Due to time restraints, I'm not going to do that. I already created the model, which I'll show you later. Okay. Similarly, I am going to typical one layout. I'm going to copy the layout which I just created, including everything, and no changes. Wait a minute, I forgot to add the slab. Okay, so I go to typical layout and apply my slab edges. Sorry, this. I use this overhang of 300 millimeter and add for the whole perimeter. And for the opening, I'm going to use 150 mm overhang. Okay, and you specify this here. Okay, I redo the same for the typical one. I could have done this copying of the floor layout after I created this slab, but never mind. I'm going to first use overhang of 300 mm and create for the whole floor slab edge. You see the green color line, okay? And then create the slab opening of with 150 millimeter overhang. That's the off the width of the wall. Okay, and do the same thing for roof. Okay, for roof, I'm going to copy the layout of typical. Okay, all. And I need to do some modifications on this. First thing is I need to get rid of all this slab opening. Okay, and sorry, delete by fence, sorry. Okay, and opening also I need to delete it here. Get rid of this visibility of this fixity. I could use this menu, or I could use this fixity tool, frame fixity. Okay, and I need to delete some beams and columns here. So first I delete some columns. All these edge columns I'm going to delete. And now I need to delete the beams. All the beams that are fully covered only will be getting deleted. The beams which are not fully covered will not be deleted. Those needs to be deleted manually. Okay, so one by one like this. Okay. That's a wall, sorry. Okay, and then the wall, I delete this 4 walls, sorry, 8 walls, 1, 2, 3, 4, 5, 6, 7, 8. And then now proceed with slab modeling. First the overhang. In this case, I'm going to use a 500 mm overhang for the whole perimeter. I don't need any opening here. And now we can start creating the story. Okay. But before modeling the story, let's first create the properties, okay, for the columns, beams. For columns, I'm just going to create three type of columns: 1 meter column, square column, okay, and then 750 mm square column, and then a 500 mm square column. Okay. So for all the interior columns, I'm going to use 1 meter, and the exterior columns, I'm going to use 750 mm. And for the first 5 floors, I'm going to use these sizes. And for the next 5 floors, I'm going to reduce the interior columns to 750 and the exterior columns to 500. And the roof is all 500 mm. Okay. So now I created the properties for the columns. Next is for beams. For beams, I'm going to use all the beams as a 500 mm by 500 mm may not be required. Say 400 mm by 230 mm T-beam. For all the edge beams, the program will automatically calculate as L beam. Okay, we can either force the program to use a specific overhang or let the program calculate as per the code. Okay, so web thickness is 230 mm, and the overall depth of the T-beam I'm going to use 400 mm. Okay, add. That's for the beam. Next is for the slab. Note that this program has a complete library of all the international floor decks, composite floor decks. For this example, we are going to use a 200 mm thick concrete slab. Okay, and I'm also going to create my mat foundation, which is 750 mm thick. Okay, now that I specify the properties, we can now assign this slab deck assign for the whole floor. I need to repeat for all the floors. Layout slab deck assign for the whole floor. Similarly for the roof, slab deck assign to a slab and 200 mm thick for the whole floor. Okay. Now that we finished assigning the floor thickness, next thing is the beam and column sizes. So I go back to the typical layout and lay out the column size, assign size. I use 1 meter column for all the interior columns, 750 mm for all the exterior columns. Okay, and when I change to the next floor layout, I'm going to assign a lesser column size because these are for the top floors. 750 mm for the interior columns and 500 mm for the exterior columns. Okay, and finally when it comes to the roof, I'm going to assign all the columns same size, which is 500 mm by 500 square column. Next is beam. Assign size, I'm going to use same 400 by 230 for all the beams. Layout beam assign size, all the beam. And even for the roof, layout beam assign size. Okay, so I finished the assignment. Next is the story information. So the first level, I'm going to use the typical floor layout. I'm going to use the plinth level as 1.5 meter and use this floor as ground level. Okay, and then from the second story to the sixth story, I'm going to use typical floor layout. The floor to floor, sorry, the second story, yeah, 6 to 6 story, I'm going to use generated automatically with a floor to floor height of 3 meter. Later on, I'll change this second level, which is first story, okay, as 4 meter. Okay, so I'm going to use this enumerator as first, and then this will be level. Okay, first level till sixth level. In fact, it will be fifth level. Okay. Instead of level, I would say story. That will be easier to so that it won't conflict with the level which RAM uses here. Okay, the first level is for the plinth, okay, which is ground level, and first story, second story, third story, fourth story, fifth story will be stopping at sixth level. Okay, I alternate the splice, generate this, add. Okay, so now we got the ground level, first story, second story, third story, fourth story, fifth story. The first story, I change the floor height to 4 meter. Change. And then, now that we created the fifth story, now we need to start from 7th level till 11th level, naming from 6th story till 10th story. Okay, so I generate floor level, floor height will be 3 meter. Okay, done. So we created the 10-story building. Totally 11 levels, 10 stories. Okay, done. Now that we finished creating the story information, we can see the model in 3D. Okay, so I forgot to change the top level, the 10th level as roof layout, okay, which I'll do now. Go back and change the story information, change the 10th story from typical to roof. Change. And I forgot also to specify the 6th story onwards, the level floor type will be typical, okay, typical 1. The floor type is not really changing, but just the column size I'll be changing for this typical layout. Sorry, typical 1 for the top floors and typical for the bottom floors. Okay, that's it. Now roof we have changed. Okay, the roof will not have opening and the lift go. Okay. Okay, so now we see finished the modeling of the building. The next remaining things, the foundation modeling and the opening modeling in our shear wall lift go. Okay, so first we'll see how to model the foundation. So I go to the typical floor layout and then show you how to model the isolated footing first. I'm going to use the spread footing for this column, this column, this column, this column, and even this, and this. And pile cap for remaining all the columns. Okay, and then a combined footing for all the shear walls which are on each face of the building. And mat foundation with the edge offset of 1 meter. Sorry, I made a mistake, so I delete put a fence and delete it. Okay, I redo it now. Model the mat. Make sure you click on the grids and not on the edges of the slab. Okay, so I finished modeling the mat. Now I need to assign the properties for this mat. Mat properties, okay, 750 mm thick for the whole mat. Okay, next is the shear wall. I need to choose the shear wall in the elevation view so that it's easy for me to add the opening. Okay, this wall is 6 meter length, so the opening I'm going to model is a 2 meter height and 1.5 meter wide, and I'm going to start to center the opening from the edge of the shear wall is 0.75 meter from the lower left. I put a fence and I use it for all this flow. Okay, and similarly for the right side, I have this is 6 meter length wall, so I need to model two lifts here. Okay. Okay, that's it. The opening is finished. Modeling, and now we can see the completed building model with the opening, beams, columns, foundations, shear walls, everything finished modeling. Okay. Now before we exit the RAM modeler, we need to apply the loads. So I go to the load, surface loads, and apply this gravity loads. Okay, which is a dead load of 1 kN per meter square in addition to the self height of all these components. Okay, live load of say 3 kN per meter square, partition load of 1 kN per meter square, and a mass of 1 plus 1.5, that's 2.5. It's useful for dynamic analysis in case if you do response spectra. Okay, that's it, and we can now apply these loads on our whole diaphragm for typical whole flow for typical, as well as roof. We may have different loading, but just for simplicity's sake, for this demo purpose, we'll use the same load. Okay, whole flow. Okay, and we can also apply the line load, point load, etc. The line load will be useful for modeling the wall load, and point load will be useful for modeling any overhead water tank load. Okay, but for this demo, I am going to skip that. Okay, and I'm going to use this data check. Integrity data check is very useful for checking the connectivity between the beams, the lateral beams and gravity lateral columns, and the walls, and finally the foundations. Okay, so now the RAM modeler, we finished the modeling. Now we can come to RAM frame for applying the loads, lateral loads specifically. But I already finished applying the lateral load, so I'm going to open up a completed example. Okay, where I also fixed the releases, member releases in the beams, the gravity beams. Remember, I was doing it only for some beams. So here I've finished modeling all the gravity beams, the releases correctly, fixed here and pinned here, because here is connecting to a lateral column, whereas here is connecting to a wall. Okay. To simplify the detailing here, I use a simply supported beam. Okay, so RAM model is finished. Now let's come to the RAM frame, and here we have the option to apply all the lateral loads. So here we have the wind loads as per many international codes, including the Euro code, seismic loads as per many international codes, including the Euro code, dynamic loads as per many international codes, including a customized response spectra by using an external file. We also have notional loads as per various international codes. We can create user-defined story forces in case if you want to create any one of these lateral loads as per your own code, which is not listed here. And then you can manually calculate it and apply it as a user-defined story forces as well. We can also create stage construction analysis. In this model, I also created a stage construction, which I'm going to show you. Okay, so these are the stage construction numbers. The plinth is the stage 1, and the first story is stage 2. The second story is stage 3. Okay, and which I can show the stages like this: stage 1, 2, 3, 4, 5, 6, 7, all the way to 10. Okay, we can view that in a full 3D view. Also, we can see one stage at one time. 3, 4, 5, 6, 7, 8. Okay, so we have created the stage results stages also. So now the wind load I applied as per Euro code. All you need to just specify is the basic wind speed and terrain category, and press OK. The program will automatically apply the wind load in all possible directions. Similarly for the earthquake load also. So just specify the directions and specify the design ground acceleration and specifying the eccentricity. Okay, and the soil type. The program will automatically apply the loads in all possible directions. Okay, I included the stage construction also. Okay, now I need to mesh the whole building. So from the physical model, the program is creating a finite element mathematical analytical model. Okay, it automatically meshes all the walls and slabs and stitches them. And now you can see this complete meshed model. Okay, the program uses a coarse mesh of 1.5 meter, so it doesn't take much time for analysis. Okay. And we now can proceed with the analysis. Select all the load types, gravity loads, lateral loads, okay, stage construction analysis as well, and perform the finite element analysis. Okay. So let's go back to our presentation now. Now we are in this second stage of modeling the building. Okay, we finished the modeling, but now we are doing the analysis. Okay, so actually we are in stage 3. Okay, so we are doing the analysis. Once this analysis is completed, we do the load combinations and then do the post-processing. Okay, after the verification of results using the post-processing, we go to the 4th stage, which is performing the gravity analysis in RAM concrete. So here we can see the load path, the reactions of all the floors from top to bottom. Okay, and then in step 5, we import these results in RCDC program to do the design and detailing of our concrete components, such as beams, columns, shear walls, foundations, such as isolated footing, pile cap, slabs, staircase, cost estimation, bill of materials, bar bending schedule. Okay, and finally, in the 6th step, we'll do the mat foundation design using RAM concept. Okay, so now we are in step 3, which is lateral loading and analysis, and now we are in the analysis stage. Since the program uses a coarse mesh, the analysis time taken would be lesser. In fact, the analysis is already completed, but because we included the stage construction analysis, which includes the creep and shrinkage analysis, that's why it's taking more time. Approximately 1 minute 45 seconds, we finished the analysis, including the stage construction. And now we can go ahead creating the load combinations, okay, which I created it already. Okay, the program can create the load combinations as per various international codes. I used Euro code to create the combinations. And now we can look at the deflector shape, and I can increase the deflection 100 times. Apply, and I can see the deflection diagram in 3D, and we can even animate them, and you can see the maximum value is 15 millimeter. We don't need to show a full cycle animation. Similarly, we can look for other load cases as well. There are load combinations, dead load, live load, and wind load factored load combinations. You can see a 18 millimeter deflection. Similarly, we can see for other load combinations as well. We can also have a look on our bending moment diagram, shear force diagram, bending moment diagram, axial force diagram, etc. Okay. To save time, I skip that. Okay, now we'll go and do a gravity load analysis in RAM concrete. Okay, so go to RAM concrete, and here we choose the code for our design. Here I choose the Euro code and perform the gravity analysis. Now the program does the gravity analysis for our lateral members as well as gravity members. Performs a live load reduction as well. And now we can see the results. Very important results would be the vertical reactions. So here you can see the vertical reactions of dead load, okay, for the 10th story, and here's for the 9th story, and here's for the 8th story. As you go down, you can see the support reactions gradually increasing. Finally, for the ground floor, we have the maximum support reactions. Okay, very useful to check, to cross-check the results manually. Once we perform the concrete analysis in RAM structural system, we are now ready to perform the design of a beam, column, shear wall in RCDC. We can also do the same thing in RAM structural system itself, but in RCDC the detailing will be much better, and also design also is better there because of the grouping feature in RCDC. So we now conclude with RAM structural system and proceed with our concrete building design with RCDC. Okay, design and detailing. Okay, so now I run this RCDC program. Okay, while we use the RCDC program, the model in RAM structural system needs to be closed. Okay, in RCDC program, I'm going to use the Stair Advance license because that is included in structural enterprise license. Okay, so I close this model in RAM structural system. Sorry. Okay, and then I go to RCDC and choose the code here as the Euro code Singapore National Annex, and note the availability of other international design code, including British code, American metric 2014, as well as the Indian code, okay, as well as the UK National Annex and generic Euro code as well. Okay, so now I'm going to use the Singapore National Annex and choose the file name here. Okay, make sure the file is not locked by RAM structure system. We already closed the file. Okay, so that RCDC can read the results of the RAM structure system file. And these are the components which RCDC will design. First, we'll perform the column and wall design. Next, beam design, slab design, footing design, pile cap design. Okay, so just give a name and then choose the element that you want to design. In this case, I choose with the column design, column and wall design. And now RCDC reads the results of RAM structure system and it's ready for the column design. Okay, so here's a column and wall layout. Here's the levels in a building, the totally 10 floors. And here's a column size for each floor, and each labeling, alpha numeric labeling is done by the program automatically. Okay, level data, level information. If there is any offset, we can also modify that here, but we can do that in RAM structure system itself. Okay, and specify the design settings here. I'll use the default values. We can also perform crack width check. And we can specify the reinforcement setting here. I'm going to use a minimum of 13 mm diameter bar. Okay, we can shift this rebar from American bar number to metric rebar diameter. And you can choose 12 mm or 13 mm bar or any bar. Okay. Choose the type of links, spacing of reinforcements. 13 mm. I have not selected 12 mm. That's why it's giving me warning. Okay. So that's the reinforcement settings. And now select the load cases. And here the load cases load type. We can specify the load type so that RCDC will understand that. I already created a template so that I don't have to redo it. So I just need to select the template and it loads this automatically, and even the load combinations, but you can create the load combinations directly from this program as well. Okay, so now that we create the load cases and load combinations, next all we need to do is hit the auto design button. The program uses the results, analysis results of RAM structural system, and goes through the hundreds of load combinations and designs all our columns and walls based on the reinforcement settings we set up in RCDC. Okay, and we can see the progress at the bottom left corner here. And you can see the column is now designed successfully. Okay, on the left, you can see the green color, meaning all the columns are safe. There's no column that is failing. The failed column will be shown in red color, and we can investigate the details of the failed columns in failure diagnostics. In our case, there is no column that is failing, so we can skip that part. Okay, so here you can see this fresh sheet showing the column number, the column labeling, the size, material, and the capacity ratio for axial and flexure and provided percentage of steel. This is a failure diagnostics, we can skip, no column is failing, and reinforcement and the links, okay, for the whole project. And you can see there are several columns in this building, so the number of rows are many. So I can simplify it by grouping all the columns that has the same size and same reinforcement by using this modify auto group option. This will take few seconds. Okay, now we can see the grouping is finished. Now the number of rows are lesser. Okay. Now we can pull out the reports such as text schedule. We have two types of text schedule, ductile and non-ductile. So here I produce the non-ductile text schedule for the column. And here you can see the column markings. They are grouped, and here you can see for each flow the size of the column and the reinforcements. Okay, and the material of steel and concrete. Okay, for the whole building in a single table. Okay, now I can pull out other reports such as detailing for all the beams and all columns. Again, this will take a few seconds. Here are the drawings, okay, the detailed drawings. So here you can see the column labels, column marking, the scale, the dimensions, and the reinforcement for the columns and the walls. Okay, and next now we can pull out the elevation details. To save time, I'm not going to select all, just a few columns. Okay, here we have some setup for the detailing. You can see the progress of the bottom left, and here's the detailing done. Okay, so for the selected few columns and walls here, you can see the elevation details and showing the cross section as well, and showing the laps as well. Okay, the bar by default, the bar stock length will be approximately 12 meter. So here you can see the lap is happening here at the slab level. Okay, but the stock length of the bar can be modified in the BBS bar bending schedule. Okay, the detailing is done, and now we can produce the design summary. Okay, this gives a table showing you the level information, the column information, the analysis results information, the percentage of steel, interaction ratio, main reinforcement as well as secondary reinforcement. Okay, we can also pull out a detailed calculation results. To save time, again, I'm going to choose only for few columns. Okay. This will take few seconds. Okay, the calculation results are now ready. So here you can see the step-by-step calculations that shows even the equations and formulas used in the code as well as the codal references. Okay, finally we can calculate the bill of quantities and cost estimation. The cost estimation can be done as by various currencies. For this example, I choose the Singapore dollar. Okay, so here we have three different types of bill of quantities. So you can choose the currency here, fill up the local rates, and now you can see the estimation in three different types. Okay. This includes the shuttering, and in case of foundations, it will include the cost of excavation as well. Okay, the volume and cost of excavation as well. In this case is the estimation for the columns. Okay. So that's it. You can see we imported the column design input from RAM structure system. We designed all the columns, and then we created schedules, column schedules, cross-section detailed drawings, elevation drawings, design summary report, calculation report, bill of quantities in three different formats. And all these detailed drawings, you can directly open it in Bentley microstation program, or you can save it as a DXF file. Okay. So first we need to save the project, and then only we can save the DXF file. Okay. So with that, I'll conclude the RAM structure RCDC presentation. I'll come back to RAM structural system. A feature which I forgot to show you, I'll show you now in RAM frame, the stage construction. Okay. So here we can actually see the stages. This is stage 1 and 2, 3, 4, 5, 6, all the way till the 10th story. Okay, useful feature. Okay, I'll go back to my presentation now that we finished the column design, and same procedure for designing our beams and as well as foundations and slab as well. Now we'll see the mat foundation design using RAM concept. So from RAM structural system, I run this RAM concept program. Okay, and here I choose the ground floor mat foundation, tick in all the default options, press OK. This will automatically launch the RAM concept program. And here you can see the model has been imported here successfully. The slab, in this case, the lift core, okay, not the slab, the mat foundation, sorry. And here I'm going to specify this upgrade modulus. Okay. Since this loadings are also imported from RAM structural system, which involves lateral load, I am using some small spring in the lateral direction as well. Okay. The units are in Newton and millimeter cube. Okay. Newton per millimeter cube. They are subgrade modulus. So from this, the soil spring will be estimated automatically. Okay. And here we can create the mesh. Okay. Create the design strips. First the spans, and then the strips in both the direction. The program will use the strips to extract the results from finite element results and to proceed with the design. Okay. So now the strips are ready now. So I go back and refine my mesh again with the same size. Now the shape of the mesh will be much more accurate. Okay. I'll use a coarse mesh just to save the analysis time and run the analysis now. The program will now do the zero tension iteration analysis. Okay. Make sure all the soil springs are taking only compression, no tension. Okay. And the program does the finite element analysis and design and detailing, and make sure all the slab is passing. In case if the slab, the mat foundation is failing, then we need to modify the thickness and rerun it. If it's failing due to the base pressure, then we need to increase the area. So first let's go and check the base pressure. Since we are not input the safe bearing capacity of the soil, the program doesn't really check the base pressure, but it gives you the base pressure as output. So we have to manually go and check the output. For example, now we'll go to this load combinations and check our soil bearing pressure plan. Okay. So here you can see the base pressure is 249 kilonewton per meter square. If this value is more than the allowable bearing capacity of the soil, then we need to increase the area of the mat foundation and rerun the analysis. In this case, we have to do this rerun, but because of time constraint, I'm going to skip that. Okay, so here's the maximum reflection, which is 2.5 millimeter. Okay, and similarly, we can look at other results such as the stress contour for ultimate load combinations. Okay, so here you can see the real stress contours, and we can cut a line to get a graph. Okay, like this, a bending moment diagram. Use Shift key to draw multiple graphs. Okay, and finally we can have a look on the reinforcement. The program provides the reinforcement for both the directions. Okay, so we'll look at the top reinforcement and bottom reinforcement, and we can modify this annotation by selecting this annotation, right mouse button, selection properties, change this program to user, and then modify this quantity to spacing, and then we can even modify the diameter and the length of the bar required. The program will modify and show you like in a different color. Okay, so this way the user can modify the reinforcement, but if you want, you can delete the complete reinforcement and put your own reinforcement by using these tools here. and then perform the analysis one more time by using this option here to use the user provided reinforcement to check. Okay, and finally we can check the transparent view of the 3D view of the reinforcement, and we can actually go for a walkthrough of this. Okay, and finally estimation. This will give you the estimation of the mat foundation, including the concrete reinforcement formwork, if there is any post tensioning also. Okay, total cost. Okay, so our slab is mat foundation is now completely designed. So we can export this drawing as a DXF file or DWG file, and we can add it to our detailing. Okay, that brings to the end of our presentation on concrete building analysis, design, and detailing. Okay. Any questions on this webinar? You can post your question at our community site. Just visit the Bentley community site, communities.bentley.com, and sign in. And then only you get this button here to create your posting. Okay. Once you sign in, you search for this topic, concrete building analysis, design, and detailing. Just use some of the keywords and it will show you the help. Okay. So select, come to this forum, and here you can post your question. As soon as you post your question, I get an email, and then I'll reply to it so that the answer will be visible for everyone and benefits everyone who attends the seminar. Okay. So to get the license for the various software that we used for this analysis, I would suggest that you have a look on our structural enterprise solution. This is a special license that gives you access to many of the Bentley structural analysis programs such as Stat Pro, RAM Structural System, Stat Foundation Advanced, RAM Concept, and RAM Connection, RAM Elements, LimCon, MicroStrand, etc. Nearly a dozen programs at a fraction of its price. Okay, so a lot of value for the license that you buy. Okay, structural enterprise. We also have our Stat Pro Connect Edition version 22 released. The top 10 capabilities you can see here. Existing Stat Pro older version users, I would suggest to upgrade them to the latest version, to the Connect Edition, so that you get all the 90 plus design codes free of cost, as well as a new physical modeler, which helps in the BIM workflow much better. It brings in all the walls and slabs from the BIM software. Okay, as well as various other features, new improvements in the latest version. Definitely will be helping you to your projects. Please subscribe to our YouTube channel, Bentley Structural, which is free. A lot of videos are getting loaded almost every day. Okay, very, very useful features. Stair Advanced Concrete Design, otherwise called as RCDC, is also included in Stair Pro Advanced, which is in turn included in Structural Enterprise License. And you have seen this features of this program today. It's available for various international codes, and the Euro code, Singapore National Annex as well as Malaysian National Annex is also available. ACI metric is already available. ACI Imperial is coming up very soon. Okay, this designs not just the standard beams and columns, but also irregular cross sections such as L shape, T shape, etc. We have a promotion for RAM Connection free trial version available. Please visit this site to get the free trial of RAM Connection. We also have our analytical cloud services with Optioneering Center. Check it out. This is very, very important for our structural engineers. This analytical cloud services has two things. One is scenario services. This allows to try new versions of STAT before you decide to roll out on the desktop. It allows you to run multiple versions of a design in parallel, and then gives you some great tools to compare the results and discuss the trade-offs between them with your customers. Analytical Insights is another great service to help you train your young engineers. The best part is both of these services and our mobile and design toolkit solutions like RAM S-Beam are all part of a single new license called the Optioneering Visa. Okay. If you're interested in trying it out for free, simply go to connect.bentley.com, sign in, and create a project to upload your STAT and RAM files. Okay, again, if you have any questions on this webinar, please visit our community site, search for this forum, Concrete Building Analysis, and hit the new button to post your question. Before that, you need to log in. Then only you get this new button, and I'll answer all your questions. Okay, thank you for attending this Concrete Building Analysis Design and Detailing webinar using RAM Structural System, RAM Concept, and RCDC. And my email address is shown here. I hope this session was very useful for you. Thank you for joining. Bye-bye.